Alright, so we're back. This is going to pertain to part B, but this is the reactions of salts and H2O. So basically you take some solid salt, they're ionic compounds, right? So they tend to break up in water, but not all of them do. So basically they can be solutions of these salts, can be acidic, basic, neutral, and that all depends on whether or not their ions react with the water. So this is a breakdown kind of what does break down with water. Cations of group 1A and 2A salts do not react with water. So they're going to be neutral in solution. So basically, group 1A and 2A, I have examples, sodium, magnesium. They're not going to break up into water, and so basically you just end up with a neutral solution. If we move to the transition metals, those cations, so you got iron, copper, gold, silver, zinc, there's a bunch of them. But basically, almost all of those are acidic in solution, so they do react with water. So you got, I have an example down here, you got iron reacting with a lot of water, and then you end up with this iron H2O complex. It's not really important. The main thing is that forms, and then you also form H3O+. As I said before, H3O+, also H+, is what's responsible for making a solution acidic. So you get H3O+ in there, it's becoming more acidic, and so that's why we get that. We move over here, it's just some other examples. These are all in the lab manual, but I felt like it would be helpful to lay them out again. So basically, over here, we got NH4+. Now this is a conjugate acid of a weak base, ammonia. So ammonia, you should probably know, it's just NH3. When it breaks up with water, it forms NH4+, and basically that is acidic in solution. It's just an example. You don't have to know that inside and out, but it's just a good example to reference. Basically, we got anions that are conjugate bases of strong acids are neutral in water. So what I mean by that is we got these conjugate bases, the anions, right? So the negatively charged ones. So we have Cl minus, and then we have, that relates to the strong acid, right? Which is HCl, HBr, HI. So you got these anions, and those are all neutral in water. So they don't react with water, and they don't form any acidic or basic solution. But then you get to anions that are conjugate bases of weak acids. Now we dealt with strong acids there, we're dealing with weak acids here. So those are all basic in solution. So you get these anions, F minus, NO2, CN. They relate to the weak acids, HF, HNO2. So basically they do break up in water. And they do get OH in there, and that's why you end up with basic solutions. Again, this is all in the lab manual. You can see where the OH comes from and where the H3O+ comes from. But yeah, that's about it. As far as part B of the experiment that we're going to go into, really all we had to do for prep, we picked a salt up, a random one. It has the molecular weight on there, so we found it, it says it's 53.4 grams. We just do some basic conversions, and we get to, we need to weigh out 0.11 grams. And basically all we did was we knew that we wanted a 0.1 molar solution, so that's the concentration we wanted. And we knew that we were going to use 20 milliliters of water. So we just did the conversion. We get 0.11 grams. We weigh it out, throw it in solution, and measure the pH. That's good.